So here is a sheet that has grid squares that are much smaller, so it can fit far more squares than you'd have in your exercise book. This is really handy because now we can start tackling larger and larger multiplications. You'll notice something a bit unusual or different about this particular sheet of paper, and that is the dark lines that are appearing. These dark lines are handy guidelines, and they appear after every 10 squares, which will make it very handy for us to find some good spots to break our arrays down into easier ones to solve. So to start off with, let's try a double digit times double digit number problem. So let's try 17 groups of 17. So first of all, if you can look in the left hand corner, I've drawn my 17 rows of 17 just by using an outline. But if you look at the little squares inside, there are actually 17 along and 17 rows making their way down that shape. To do this, I would make sure that I trace my top line and my height line on a dark guideline, because that's going to help me when I come to break my array up. Of course, as a good habit, I've written the number 17 along the side to remind me that that's how many rows I've got, and I've also written 17 along the bottom to remind me I've got 17 in each row. Now I'll just zoom it in so it's easier for us to see, and it gives you a chance, if you want to pause your screen, to actually get in there and check me and count that there are actually 17 in each row and 17 rows going down. Again, there are no tricks here. Now the first thing I'll do to tackle this 17 rows of 17 in a large array is to break that array into some smaller arrays that are more friendly to solve. So I can see the really dark guidelines on my grid squares here that are going to help me. And there's one dark grid line going through the almost center of this square. It's a little bit lower than center. And I know that that grid line is actually happening after 10 squares down. So it's 10 rows down. So I'm going to cut my array at that spot using green. So I have put a border around the array that is now 10 rows of 17. Now the remaining array that is in the red section below the green box is still a section that I need to solve. And if I look at that closely, it is 7 rows of 17. Now that is still a pretty unfriendly times table for me. So I'm going to break that down further, and I'm just going to break off the first 5 rows because I'm happier with my 5 times tables. And if I circle the array that is 5 rows of 17 in yellow, it would look like this. And so that is 5 groups of 17. Then the only remaining part of the original array, which is at the bottom in red, is actually just going to be the final 2 rows. So that's 2 rows of 17. And I'm going to circle that in light blue. So here I've now broken up 17 groups of 17 into first 10 groups and 5 groups and 2 groups. Or I'll restate that. I've got 17 rows of 17, and I've broken it into 10 green rows of 17 first. Then I'll solve 5 yellow rows of 17, and then I'll solve 2 light blue rows of 17. And each of these I am much more confident with solving. To solve those, first a 10 times table. I'm confident that that will give me 170. 5 groups of 17 would be exactly half. So the yellow section is exactly half the size of the green section. So half of 170 is 85. And the blue section is just a double 17 would give me 34. Now I just add those all together to find how much my array totals to. And that would be adding 170 plus 85 plus 34, and 289 is my answer. So 17 times 17 is quite a difficult times table. However, by breaking it into those 3 easier ones for me to solve, I can then add those together to find my total. Okay, so we've now successfully gone through the way that we can use an array with grid squares to break it into smaller arrays to more simply solve much larger multiplications. So I'm just going to end with one final example, and this is the same method again, but this time I'm just going to go a little bit larger. So you've got one more to refer to. So we're going to now look at 43 groups of 36. So as we can imagine, it's double digit times double digit. The smallest number we're dealing with is 36 out of those two numbers. So we are going quite large. To start with, same process. No tricks here. We just draw a line that's 43 squares long and another line for our box or our rectangle that's 36 squares long. So we're going to, in this instance, I have done 43 squares as my height and 36 squares as my length, which means I'm going to have 43 rows of 36. I could, if I wished, I could decide to flip that times table. So I could instead cross that out and do 36 rows of 43. And I would just have the same shape, but it would be turned on a right angle. So it would actually become 36 rows of 43. So I have that choice if I want to. But we're going to stick with the green shape just for this example, which is 43 rows of 36. And we can see we just follow the same process. I'm just using the black guidelines on my sheet. Don't have to use those, but I like them because those guidelines are every 10, and 10 is my friend. It's a very easy times table to deal with. So I just break it up into 4 groups of 10, plus the last 3 down the bottom. So of course 43 is 10, 10, 10, 10, and 3. These are 10 groups of 36, because if we look along our array, there are 36 in each row. So, of course, all of them are 10 groups of 36. They are all the same. Each of those red rectangles is the same, so they're all the same array. So I'm just solving it once and then adding them together. And then I've got my remaining 3 groups of 36 to solve. So just to move my 4 times 36 out of my way so I can put my answers in. First 10 groups of 36 is 360. Once I've solved that, I've actually solved the answers to the next 3 arrays under it because they're all the same. And then I need to tackle my green array, which is smaller, 3 groups of 36. Well, I could double 36 and add one more 36, and that will give me 108. And then I just go through the process of adding all of those together. And that would give me 1,548. So there you have it. The method will work for any array of any size, and we're only limited by the size of our grid page. So we can go larger and larger and larger. Once we're very confident with this skill, we actually will then be able to remove the grid paper altogether. And we'll be able to do this by imagining where those grid squares would be. So for example, for this one that we just solved, I could very easily just decide to draw a large array, which I'm imagining is 43 rows and 36 in each row. And then I can go through that process of thinking to myself, well, if it's 43 rows, I can break my 43 rows into 10 rows, 10 rows, 10 rows, 10 rows to make 40, and then the remaining 3 rows. And then I would go along and decide to, remembering that it's 36 rows, say 10 rows of 36 would be the top one, 10 rows of 36 would be the next one, and so on. And I'm just solving it all by having a very strong visual understanding in my memory of what an array is. I don't need to actually use the grid squares anymore. And so if I get forgetful, that's where writing my numbers down the side and along the bottom are helpful. I can say, that's right, my last array is 3 rows and they're rows of 36. So that would be 3 rows of 36. And I go through the process of solving them all and getting the same answers that I had previously. So there you can see are my totals, same as before. And we can add those and find our way to the answer of 1,548. Yet again, it's exactly the same array. It's the same grid squares inside. However, I'm just visualizing it or using my imagination to understand what my sketch diagram represents without using the actual grid squares. If this last step is a little bit tricky for you, I encourage you to stick with the grid squares. Practice, practice, practice. Stick with some smaller numbers where it's a 2-digit or 3-digit number multiplied by just a single digit to start with, and then move on to double-digit numbers times double-digit numbers. Take your time, make sure it's all making sense to you and that you are able to make these groups of 10 or break them into easy to solve arrays. And I promise you it'll start coming together and making more and more sense.